Hello everybody and welcome to the 32nd webinar in the RUS series. My name is Georgia Karadimou and in this webinar we will analyze the explosion that took place at the port of the city of Beirut, the capital of Lebanon, in August 4th, 2020. We will learn how to assess the damage caused using Sentinel-1 and Sentinel-2 products. So let's have a look at the structure of this webinar. We will have an introduction about the study area. We will continue with some information about Sentinel-1 and Sentinel-2 satellites, and we will have a quick introduction for those of you who do not know what the RUS service is about, followed by some recent updates included in the project. Then, we will continue to the exercise in the RUS virtual machine and a Q&A session will follow. The webinar will last around 1.5 hours. And please be aware that it is being recorded and you will be able to repeat the exercise by yourself later once it will be uploaded in our YouTube channel and our training website. Please also know that it is advisable to start sending us your questions immediately as soon as you have one and throughout the webinar. And with my colleagues here, we will try to answer to as many of them as possible in order not to have too many questions accumulated for the Q&A session. Now let's have a look to our study area. On 4 August 2020 in Lebanon, at around 17:55 local time, a fire broke out in Warehouse 12 at the port of Beirut, where a cargo of 2,750 tons of ammonium nitrate was stored, followed by two explosions a few minutes later. The first explosion produced a large cloud of smoke, damaging heavily the warehouse, while the second, that was caused by nitrogen dioxide, a byproduct of ammonium nitrate decomposition, produced a red-orange cloud surrounded by a white condensation cloud. The consequences were severe in many fields and levels. It is estimated that more than 200 people lost their lives, more than 6,500 were injured, and more than 300,000 people went homeless since homes as far as 10 kilometers away were damaged. The blast affected over half of Beirut, with the cost to be above $15 million in property damages. Within the port area, the explosion destroyed a section of shoreline, leaving a crater around 124 meters in diameter and 43 meters in depth. Experts estimated that the explosion was one of the biggest non-nuclear explosions in history. It was detected as a seismic event of magnitude 3.3. It was felt in many countries such as Turkey, Syria, Israel, Palestine, and parts of Europe, and was heard in Cyprus more than 240 kilometers away. The Lebanese government declared a 2-week state of emergency response to the disaster. Now, let's see quickly some information about the Sentinel-1 data we will use. In this exercise, we will be using SAR data provided by the Sentinel-1 satellite. The Sentinel satellites are included in the space component of the Copernicus program of the European Commission and the European Space Agency. The Sentinel-1 mission is formed by a constellation of two twin satellites faced at 180 degrees to each other. It is an active sensor working on C-band. It includes a right-looking active-phased array antenna, providing fast scanning in elevation and azimuth, and it provides data with a short repeat cycle of 6 days and with different imaging modes. Here, you can see the 4 different acquisition modes, of which we will use the IW, which is meant for land applications, and the 4 products of each mode, of which we will use SLC, since it contains phase information that is necessary for estimating the coherence between two scenes. In the next slide, you can see the 3 subswaths the interferometric wide swath consists of, and the 9 bursts of each subswath. In order to derive the coherence between two radar images, they not only need to cover the same area, but also to belong at the same orbit and have the same geometry. The closer to 1 the value, the more coherent the image is. For this exercise, we will also use multispectral data provided by the Sentinel-2 satellite, so let's talk a bit about Sentinel-2 as well. Sentinel-2 mission carries a passive sensor and is formed by a constellation of two satellites as well, Sentinel-2A and Sentinel-2B. They are passing at a polar orbit, phased at 180 degrees to each other, and the multispectral instrument it carries has 13 spectral bands in frequencies of the visible, near-infrared and short-wave infrared parts of the electromagnetic spectrum. The spatial resolution varies based on spectral band to 10, 20 or 60 meters. At the equator, it has a revisit time of 5 days. Let's continue now with some more information about the RUS service. RUS stands for Research and User Support for Sentinel Core Products. It is an initiative funded by the European Commission and managed by HAZA with the objective to promote the uptake of Copernicus Sentinel data and support research and development activities. The service provides a free and open scalable platform in a powerful computing environment, hosting a suite of open-source toolboxes pre-installed on virtual machines, which allow you to handle and process the data derived from the Sentinel satellites. RUS also provides a specialized user help desk to support your remote sensing activities with Sentinel data and a dedicated training program. Let's talk now a bit more in detail about the training program and the updates of the project. From now on, we will be offering our services in, let's say, 2 different categories based on the RUS VM availability to users. The first category includes the RUS training activities. We will continue offering face-to-face trainings in virtual classrooms, our monthly webinars providing support to webinar replay, as well as support to external training organization and operations. The second category is about individual users and R&D projects. For all the training activities, RUS VMs will be provided to the users as following. Each face-to-face training and virtual classroom event will consist of around 20 participants. The type of the VMs will be provided based on the training category, together with the ICT support during and after the session. In the case of extension, the maximum duration will be 1 month. The PDF tutorials will continue to be available to everyone via the RUS Portal, and those who will receive a VM for webinar replay will not exceed in duration the 2 weeks. For the external trainings, 30 VMs maximum will be provided per event, and the participants will benefit from the remote support from our ICT team. Moving to the individual users that want to perform any project, the standard RUS VMs provided so far will not be available anymore, but instead the solution of the Docker container image will be offered. It will contain the RUS virtual environment, and our ICT team will provide the necessary support for accessing the Docker, installing the selected RUS tools on your own infrastructure, and enriching the RUS training kits. You can read more information about the Docker at the link provided on the right. In these websites, you can find all the information about the project in our RUS portal here on the left, so I recommend you to check it after the webinar to get familiar with the service and find more about the updates of the project, register and request a service. On the right part of the slide, you can see and visit our training page, where you can find announcements for our upcoming webinars and events, the recorded videos with the Q&A documents, and our e-learning material, which you can use and practice by simply creating an account. As I mentioned in the beginning, we also have a YouTube channel where you can find all the videos of our previous webinars, and you will also find this one in a couple of days. Now let's move to the RUS VM in order to start our exercise. Here we go and we log in. And this is how it looks like. We have all the necessary software pre-installed, and now the first thing I want to do is to open an internet browser and download the products we want to use for the exercise. So I click here on Firefox, and we go to Sentinel Hub. So we go down here to Open Hub, and if we don't have an account, we create one, we sign up. If we have one, we insert our credentials and we log in. Once the login is successful, we zoom in over the area of interest, which in this case is Beirut in Lebanon. So let's zoom in a bit here and let's create a small rectangle over Beirut. Once we do that, we go here on the left and we insert the parameters. What we need is 3 Sentinel-1 images, 2 before the event and 1 after the event, so that we create 2 pairs, 1 pair with the 2 images before and 1 pair with the 1 image before and the 1 after, in order to derive the coherence and see the differences from the one time period to the other one, so that we have all the damage recorded with Sentinel-1. Let's set the sensing period, the period we want to search in the catalog to find the products. So as the start period, let's go and let's put, for example, July 25, 2020 until, let's say, August 6, 2020. We select Mission Sentinel-1. So first we will check what's happening with the Sentinel-1 data and then with the Sentinel-2. In the product type, we select SLC. In the sensor mode, we select IW. And if we know the relative orbit number, which in this case we know it, then we insert it so that we have results only from this pass. In this case, it is 21. Once we have everything inserted, we click on Search. We see that we have 3 results. The one image was acquired on 25th July, the other one on 31st July, and the third one on 6th August 2020. They are all of the same pass, they cover the area of interest, so we just click on this icon here to download each one of the products separately. We click OK, and the download starts. Once all 3 products are downloaded, we can move them to the folder we want. Remember that in every product you can go in this icon, View Product Details, and once you click it, you have a quick look over the area, and if you go a bit further down, you will see some extra information about the product. So this is how we found that the relative orbit number we want is 21. We found one image that covers our area, and then we went here in the details, we saw 21, and we asked in the search menu to find all the images of 21 relative orbit number over the time period we set. Okay, I'm closing that. And let's go back now. Let's click up here on the left. Let's deselect Mission Sentinel-1 and let's go to find 2 images, Sentinel-2 images, one acquired before the event and one acquired after the event. In this case, we will set a different sensing period. We will set from 24th July until 18 August 2020, and we will select Mission Sentinel-2. As product type, we will select this one. Let's click on Search. And we see here that we have 6 results. From all those results, if we check the availability of the images, we can see that this one, acquired on 24 July, seems quite cloud-free over the area of interest, while the next one, the 29 and the 3rd, which have been acquired before the event, they seem to have quite a lot of clouds. Also, if we go a bit upper, we will see that the post-event images on 8 and 13, they have quite a lot of clouds over the area, while the one at 18 has obviously less clouds. So the 2 images we're going to select for Sentinel-2 will be the one on 24 July 2020 and the one on 18 August 2020. Again, we click here and we download both of them. Now that we have the products downloaded, we can close the browser and we can start with our processing. Okay, so let's go and open Snap. I will open now a folder where I have into the shared training HAZA08 Lebanon damage assessment, and I will go in the original where I have moved all these 5 images I downloaded, the 3 of Sentinel-1 and the 2 of Sentinel-2. Let's start the processing with the Sentinel-1 images. The first one I will load is the one acquired on 25th July. So I drag it and drop it here on the left on the Product Explorer window. I continue with the next one on 31st July and finally the last one on 6th of August. Once I have them all loaded, I can expand here on the left and see the folders it contains. If I expand the bands, I can see that it has intensity, VH and VV in both polarizations of all the 3 swaths, the IW1, 2 and 3. Let's open now all the 3 of them for intensity IW1 VV. We just double click and it's gonna create the image on the right. We repeat the same for IW2 and also for IW3. Once all of them are opened, we go now here on the world view in order to see the location of the products over the globe. So we go here, we zoom in, and now let's see something. Let's go here to Window, Tile horizontally, so that we have all these 3 bands opened in parallel. Let me go back to the Navigation tab again and make sure that we have these 2 options selected in order to synchronize the views and the cursor across the images. Let's click here in order to have all of them in full zoom. And once that we have the first, the second and the third, if we go now again back to world view, we will see that here the sea is on the left part of the image as we see it, while here it looks to be on the right. So this image, this SAR image, looks like it has been mirrored and upside down. This is happening because, as we said, these products were acquired during the descending path of the satellite when it was moving from north to south. But don't worry, we will fix that later. So right now I'm gonna close them. This was just to visualize them. I will close them and we will start the processing. We need to start by going and creating a processing chain where we will put the images acquired before the event together, and then where we will put together the one image acquired right before the event and the one after the event. In order to do so, we go to Tools, Graph Builder, and we will build in here a graph. Let's right-click on the right operator and delete it, and we will add it a bit later. So this part up here, the white one, we will insert all the operators, and down here in the tabs, each operator will create a tab that corresponds to it. We will insert the parameters we need for this processing. So we have one read operator in order to read the first image, and we need a second one in order to read the second image. So we right-click, we go to Add, Input, Output, and Read, and we add it here. For every image, the important first step we have to do is to split it, is to select the swath our area of interest belongs to, and also select the proper bursts, because we don't want to process all this information taken by the satellite. It is going to take a lot of time and occupy a lot of space. So we will right-click, we will go to Add, Radar, Sentinel-1 tops, tops are split. And we will connect it with a read operator by going on the right side of the read, click on this red arrow, and drag it and drop it over tops are split. We repeat the same for the read operator for the second product. We go to Add, Radar, Sentinel-1 tops, tops are split. And then we need to add to both of them the apply orbit file operator in order to get accurate velocity and position information. These orbits, we go to add, radar, apply orbit file, and we connect it with the topstar split, repeating the same for the other one. They become available a few days after the release of the product. Once we have done all the pre-processing for each image, we need to put them together. And how do we do that? By co-registering them. And for this, we need two operators. The first one, we go to Add, Radar, Co-registration, Sentinel-1 Tops Co-registration, back-geocoding. So it will read the information of both of them and will put them into one. And we connect both operators. And now we continue with the second part of it, which is Add, Radar, Co-registration, Sentinel-1 Tops Co-registration, Enhance Spectral Diversity, and we connect it to the back-geocoding. Finally, as we said, we right-click and we add in the input-output the right operator in order to have our final result of this processing. Once the graph is created, we go here to Save. We choose the folder we want. For example, I have chosen in the HAZA08 Lebanon Damage Assessment the auxiliary data folder I have created. We give it a name. Let's name it Graph Sentinel1 Part 1. And we click Save. Why do we do that? We do that because if we want to reuse it, we go up here to File, Load Graph, and we load the graph that is already saved. Now let's go to insert the parameters one by one. In the first Read tab, we will put the first product that was acquired before the event, which is on 25th July 2020. It's already selected. On the second tab, which is the tab Read to, we will put the other product that was acquired before the event on 31st July. On the topstar split, we're going to insert the parameters. First of all, if we go here on the right and we click, we zoom in over the area of interest. We can zoom in manually a bit more. Here you see that the subswath IW1 that is selected by default corresponds to this area. But what we want is the area here on the left, which is the IW3, the one we select. From polarizations, let's use only the VV. We do not need to use both of them. And we now need to set the bursts. We need to be sure that the bursts we select are overlying the area of our interest. In this case, for the first product, we need to select only the burst number 5. But if we do so, the processing will fail. So we need to select minimum 2 of them. So let's select 5 and 6. 5 and 6. We click here on these small parts and we drag them towards left or right, depends on the direction, in order to select the proper bursts. Now for the second one, in the next tab, Topstar Split, again we need to go and select the subswath IW3, select the VV polarization. Let's zoom in again, let's zoom in a bit more. But in this product, you will see that the appropriate ones, the appropriate bursts, are the 3 and the 4. It doesn't matter that they don't have exactly the same numbering like the image before, but the most important is the actual coverage that we have over the area of interest. We move to the next one, which is Apply Orbit File, and we just select Do Not Fail if New Orbit File is not found, just in the case that you have some very recent product that hasn't available this precise orbit information yet. We do the same for the next one, and in the back-geocoding, in the digital elevation model, we can leave it by default, or let's select SRTM 1 second, and we also select the output deramp and demode phase. In the next one, we go to Enhance Spectral Diversity, and we leave all parameters as they are. And finally, on the right one, we see that the orb of the apply orbits and the stack, which correspond to backcheck coding and has spectral diversity, these suffixes have been added. In order not to have all these names, I will just remove some of them, and I will actually name it as following. I will name it as Sentinel1 IW SLC 2020-07-25, which is the first product, and 2020-07-31, which is the second product, orb stack. And I will choose here in the directory the folder that I have under HAZA08 Lebanon Damage Assessment, the processing folder. I just click here and I select the one I want. I click on Run and I get the result appearing on the left side here on the Product Explorer. Then I want to repeat the same for the second pair of images, the one that was acquired before the event and the one after. So I will go up here to put the parameters quickly. Here I will select this product of 31st of July. On the second read, I will select the product of 6th August 2020. And then in the tops are split, I will keep the IW3, the VV. For the product of 31st of July, we said that we need to have the bursts 3 and 4 covering the area. And then on the other one, we need to have the bursts 4 and 5. So everything now is set. Apply orbit file in both of them is already selected. In backcheck coding, again, we have inserted the parameters from before, enhance spectral diversity as well. And on the right one, we see again that it's giving such a long name. And we rename it again, just keeping only the necessary information. Sentinel-1 IW SLC 2020-07-31, 2020-08-06 this time. And we click Run. Since we have this done, I'm gonna close the graph builder and I'm just gonna load you here on the left the results. I will go to the processing folder. First, I will add the first co-registered image, and then I will add the second co-registered image. If I expand this and I open the band, I see now that it includes only the intensity IW3 VV polarization of the master, which was acquired on 25th of July, and of the sleigh on 31st. The same is happening also for the second product. It is having the result of the image on 31st and 6th of August. Let's close those. And let's continue with the next step. Why did we create that? Because we want to derive the coherence of each product. How do we do that? It is reading the information of both images and it is estimating how well correlated those two images are. So from the first pair, the correlation will be quite good because we do not have that many differences over the area, while on the second one, the correlation will be way worse, let's say. Once we apply the next necessary steps, we will do the final one that we will detect the changes that occurred between the first and the second pair of images. For this, we need to create a second graph. So we go again to Tools, Graph Builder, and we will insert the following operators. Again, we delete the right one, and we have the read. As read operator now, in here, we will insert this stack product, which was the output of the previous graph we had built, and it was created on the right operator. Let's build the graph first. Once we put that, we need to go to Add, Radar, Interferometric, Products, Coherence, because we want to create the band of coherence. And we connect it to the read operator. The next one we will put is the burst. We go to Add, radar, Sentinel-1 tops, tops are dispersed, and we add it here, and we connect it to the coherence. The next operator will be the multi-looking operator because we want to obtain square pixels. We right-click, we go to Add, Radar, SAR Utilities, Multi-Look, we add it and we connect it. We now want to geocode the product. So we right-click, we go to Add, Radar, Geometric, Terrain Correction, Terrain Correction. We add it here and we connect it. Once this is done, we will see that this is a big area that we don't really need it, and we only need this small part over the port. To do so, we will create a subset. We will right-click, go to Add, Raster, Geometric, Subset. And finally, once all these steps have been done, we will create the output by just going to Add, Input, Output, Write. And we will connect it as well. Now that we have that, we go again to Save in the folder that we want, and we name this one as Graph Sentinel-1 Part 2. And we click Save. Let's set now the parameters. We have the Read tab, where we will insert, as we said, the first of the two stack products. In the coherence one, we will go down here, and in the coherence range window size, we will write 20, and automatically you will see that the azimuth window size also changes to 5. In the tops are dispersed, we leave it as it is. In the multi-look, we see that the source band is the band of coherence that has been created on here on this step named coherence. And in the number of range looks, we write 8. The azimuth looks becomes 2, and the mean GR square pixel becomes around 27, which is the number that we want for Sentinel-1. Next, in the terrain correction, as source band we leave the 1 as it is, and basically we leave all the rest parameters as they are. And when we go to subset, we go down here and we select geographic coordinates. And down here in this area, we will insert the well-known text that defines the area that we want to be subset. But first, as I said, just go here, zoom in to see the area with this red, the area that covers our case study, which is the 2 bursts that we have selected before. In order to copy this one, I will open another folder and I will go in the shared training HAZA08 auxiliary data, and I will open the one named expressions, and I will copy this one, the polygon with these coordinates. I will copy it, paste it here, and then I will click update. When I click update, I see in here the little small area that has been defined as the subset that we want. And finally, when we go to write, we see these suffixes that have been added at the end, for coherence, dispersed, multi-looking, and terrain correction. Also the subset, which is in the beginning, but let's take it and just simply put it at the end. Again, we have the directory that we want, the folder that we have selected, and we click Run. Having done that, we go again back, tab by tab, and we insert this time the second stacked product. The rest parameters will remain as they are because we have already defined them before. The only difference that we have is that here on the right, this name will be corresponding to the second product, so I'm just gonna take again the subset from the beginning and put it at the end, and then I will run it. In both cases, the products will appear on the left on the Product Explorer. So I'm closing again the Graph Builder, and I'm opening here the results of these two. The first one and the second one. So if I open, for example, the first one and I open the bands, I clearly see there is only one band, and this is the band of coherence. So let me open it. Here it is. And also let me open the other one that refers to the coherence of the second pair. If I put them side by side, by going here, I see some differences. Over here in the center, this part used to have white pixels, while here it is having more black pixels. So far, this is a very good result that we have from our processing. What is the next step we want to do? We want to get the information of this image and of this image and process them in such a way that we will have a final product that will show us what has changed between these two images. How to do that? First, we need to put those two in one product, and once we have them in one product, we will calculate the changes between these two bands. How do we put them together? We need to stack them. We go here in Radar, Co-registration, Stack Tools, Create Stack. Here in the Create Stack, the only two we need is the two final products, the number 6 and the number 7. Just to be quick, let's click here Add Opened, and here on the left it will add all the 7 products that are already opened here on the Product Explorer window. But we don't need the first 5, so we select them and we click here and we remove them. Now that we only have the 2 products that we want to put together, we just refresh and we get all the necessary information. Next, we need to create the stack, so we go to this tab and we see that as master is selected the pair that contains the information of the 2 images acquired before the event, and the other one will be the slave. In the resembling type, we leave it as it is, none. And in the initial offset method, we select product geolocation. Then we go to the right tab and we see that this stack has been added again at the end as a suffix. Having the proper directory, we just click Run. Let me load now the product, this result. I have it here. And if I open the bands, now I see that it contains both bands together, which is what we needed. I will close these 2 views, and now I will perform the final step we want for this kind of processing in order to get the changes in the coherence and find what is the damage over this area. We select this product and we go to Radar, SAR Applications, Change Detection. In this tab of the parameters, as source product, I keep this one, the last one that we have inserted, and you can see that change has been added at the end as a suffix. We check again the directory to be the one we want, and in the processing parameters, we keep both bands as source bands, and we just click Run. The result now is this one, and I will load it immediately. It contains this one, that in the bands it is having the ratio, and in the masks it is having the ratio change. Let me open both of them. I will tile them again. So this is what we see. On the left we have the ratio, and on the right we have the ratio change. This is the final result. But can we make it a bit more clear to understand better what is happening? Let's do that. Let me close the ratio change and focus only here in this one. We have centered it over here. If we go to the color manipulation tab, we will see that down here we have these three sliders that they have some colors. We can leave them as they are, but we can give them some colors to make it more easy for ourselves to understand it. I'm gonna put, for this area that is having the higher values, I'm gonna put it with a red color, so I will just click here and select red. And in here, the one between, I will simply put it as white. So it seems that we start to understand some things. We will add some sliders in the area over here in order to distribute a bit differently the values in different classes and have better visualized results. I have already created these sliders and I have saved the color palette, which I'm going to insert right now from here. I will import the color palette, the damaged Sentinel-1 chains 1, and I will open it. Here I select no, and here you can see that we have these extra sliders, and we see that with red we have somehow categorized the severity of the damage. With red are the areas that have been damaged the most, and here, based on this color scale, we see with yellow those that have been less, and black those that have not changed almost at all. This is the last part of it, but let's also try to have it even more clear in our eyes. So let's insert now another color palette, the damaged Sentinel-1 chains 2, where the only thing we have done is that we have kept exactly the same color palette. Of the last two sliders on the left, we have turned them into 100% transparent so that we see with the three colors the areas that have been damaged. So now that we have finished with that, we only need to select the product and go to File, Export, GeoTIFF, select the folder that we want to export them, and just go here and leave the name as it is with a TIFF at the end, and we click Export Product. And this is it. Now we quickly will go through the Sentinel-2 data in order to get the results of them, so that we also put them in the GIS afterwards. Let me close now Snap and open it again. I'm opening it again. And now I will go again to the original folder and I will load the Sentinel-2 on 24th July and on 18th August 2020. Again, we can go here on the world view and we can see where they are located on the globe. We can right click and go to Open RGB image window and select the one with natural colors where it's using the bands 4, 3 and 2. Click OK in order to have it. And also we can go right click and go to Open RGB image window and create another one with false color infrared, which is using the bands 8, 4 and 3, and we click again OK. Now that they are both opened, again we go to Window, Tile horizontally, and now we will zoom over the port that we are interested about. And we will do the same with the second image as well. We will right click and go to Open RGB image window and we will create one with natural colors. And now that we have them both, we will just go to Window, Tile horizontally. We will put them side by side and we will zoom over the port that we are interested. So here on the left we are having the image before the explosion, and on the right we have the image after the explosion. we can notice immediately some basic differences. We can see here on the right that the port has been destroyed. We can see here this crater that had been created because of the explosion, and also we can clearly see that all these buildings and all these warehouses that have been on the left image before, they are not here anymore on the right. Now we will process quickly these images in order to have the damage assessment of the optical data as well. Let me close them both, and let's create now another graph by going to Tools, Graph Builder, where we will insert all the operators we need. First, we delete the right operator again. So as we said, Sentinel-2 is providing the bands in multiple resolutions. The first part we have to do when we are working with the Sentinel-2 image is to resemble them so that they all have exactly the same resolution. So we will go here, right-click, Add, Raster, Geometric, Resample, and we will add this operator in order to have all the bands in the same resolution. Otherwise, we cannot continue with the processing, with any processing. Once they are resampled, we will create again the small subset we did before, Raster, Geometric, Subset, by putting exactly the same parameters, and we will finally write the output. Add, input, output, write. So, in the read one, let's put first the first product of the two. In the resample, let's select Define size of resample product by reference band from source product, and let's select band 2 that has resolution 20 meters. And down here we do not change anything else. In the subset, let's subset all the bands contained in here. Let's go down in the geographic coordinates. Let's zoom in again to see the location, and let's go here in the expressions and copy this polygon and paste it down here. And once this is done, we click Update, and we see that this yellow rectangle has been created again, defining the subset of the area. Finally, at the right, let's shorten a bit the name. Let's keep only the date that we want, the type of the product, and let's put the subset again at the end. This is up to you. We select the processing folder that we want to save it, and we click Run. Remember that again here, if you want, you can go to Save, you can select the path you want, and name it as Graph Sentinel2. You click Save, and this is it. Then we go back and we select as read the second product. We leave in the resample the same parameters as we left before. Subset again has the same coordinates, but now in the right, we put again the appropriate name by just keeping the necessary information. And we click Run. I can close now this graph builder, and I will load the results on the Product Explorer window. The first one and the second one. Now I can just go and right-click, open RGB image window, and create an image of a natural color, and we can see that it contains only the subset that we have said before. In order to get the differences between the two images, they have to be together. How do we put two Sentinel-2 images together? In Raster, Geometric Operations, Collocation. We select as a master product the first one, which is the subset of the image before the event. And we will add in the slave products by going here, Add Products, And we will select the subset of the second product, which is after the event. We need to click here and we click OK. In the name, let's name it as Sentinel-2 and let's put the dates of the two images that we are working with, which is 2020-07-24 and 2020-08-18. And let's keep the collocate as well. Again, select the appropriate directory. And in the name, let's rename that to 2020-07-24 and the other one, the slave one, to 2020-08-18. Now we can click Run. Let me load the result of that. And if I open it, I can see now that in the bands it is containing both the bands of the first product and of the second product together. Now I can continue with the final steps of the processing that both images are together in one. Let me close this view again. First, I want to have the result as I have it with the Sentinel-1. I don't want to have any sea around. That's why we will select this one. We will go to Raster, Masks, Land Sea Mask. We will select this product as it is and we will mask it. The MSK is added at the end. And in the processing parameters, we want to mask out the sea. In the source bands, we will select only the B8 of the first product and the B8 of the second product. These are the two bands we're going to work with. And we will click Run. And I will just load the result. Again, if I open it, I see that we have both bands in here. If I open now both bands and I put them side by side, we can clearly see again the differences between the two images. If we zoom in a bit more over the port, we can see what are the results. But how will we find the changes between them? We will just go here, right-click, go to Band Maths. We will name this band as Chains Sentinel-2. We will deselect this one, the virtual save expression only, because we want to store the data. And we click Edit Expression. Here we will simply select the first one minus the second one. We will click OK. We will click OK again. And here, if I put them all together, we will see what has changed over this area. It is clear that here with black, we have the main areas that have been affected of this damage. If we go again to the color manipulation, we can do what we did before. We can go here, import a color palette, the one named Damage Sentinel-2, and we can see in red color the areas that have been affected the most. Next and last step in Snap is to select this product, go to Raster, Geometric Operations, Reprojection, select this product, the last product. The reprojected will be added at the end. In the projection parameters, we'll leave them as they are, and we click Run. And now we add the final result, the reprojected one. And if I open it, let me close the previous ones. Again, I can insert the same color palette. I can see that it is reprojected. I go here to File, Export, GeoTIFF. I go to the folder that I want it to be stored, and then I go to Subset, Band Subset, and I select only the Sentinel-2 chains that I want to export. I click OK, export product, and this is it. We now close Snap and we open QGIS. We go here and we load these results. We load the TIFF of Sentinel-1 and we load the TIFF of Sentinel-2. We put the Sentinel-1 first. If we right-click and we go to Properties, we can simply click on Style and load the style that I have already created for you. In the tutorial, you can find more analytic details on how to create your own style. But here I just click Load Style and I select Damaged Sentinel-1. I then go to Transparency and I write to Additional Node Data Value 0 and I click OK. If you remember, this is the result that we had in the beginning with this red color. Apart from this color palette, if we right-click and we go to Properties, we can have again here in the symbology, we can load the other style we had created before, which is this one, and we see more colors based on the severity. And the last one that we had done was to right-click, go to Properties, and load the style that we had made transparent the last two slides. So this is the result that we get. This has been done for Sentinel-1. Now let's deselect Sentinel-1 and select Sentinel-2. Right-click on it, go to Properties, and load the style we have created for Sentinel-2, which is the damaged Sentinel-2. Open it. Again, in the transparency, we add 0 and we go OK. And here it is. We can see the result of Sentinel-2 and the result of Sentinel-1. Apart from that, what else we can do is we can add some background. We can go to Web, open Layers plugin, Bing Maps, Bing Aerial. Let me select now with labels and it will be loaded. And here we see that with the last style that we have loaded, the one that we have made it transparent, we see only the areas that have been damaged with these colors. Now you can drag this one below Sentinel-2. You can deselect Sentinel-1 and you can see how the results of Sentinel-2 processing look like over this area. This was also the processing using QGIS. We can now close it. So, before moving to the Q&A session, let me tell you again that you can repeat this exercise by your own if you want to practice, or adapt the methodology to your own application. For that, go to the RUS Portal, register and apply for a virtual machine. During that process, you will just need to specify the training code HAZA08 once needed. You will then receive the training kit that contains the PDF of the step-by-step guide and the auxiliary data. Also, if you simply want to download the PDF of the tutorial, you can go here to the RUS Portal and under the RUS Library menu, click on Train with RUS, select the Risk Monitoring tab, and you will find the HAZA08 tutorial uploaded. This was all from my side. Here you can see where you can reach us for any questions you may have. Thank you very much for joining, and I will now give you a couple of minutes to post your questions and I will be back to you for the Q&A session. I think somewhere here we can close our webinar. I would like to thank you very much for attending. If you have any other question, please send them to us here in the contacts that you see. We hope you liked today's topic, and please let us know for anything else you would like to learn. Thank you very much and have a nice day.